Supercharge your Dynamo graph with Civil 3D Toolkit. My name is Jowenn Lua. I'm an implementation consultant from Autodesk. About me, I got over 17 years experience in design and construction. I got a degree in BS Civil Engineering and Master in Business Administration. I'm a regular Autodesk University speaker, and I'm highly active in Civil 3D and Dynamo BIM forum. In the past, I've been doing a lot of Autodesk beta testing. Our learning objective today is to be familiarized and use Civil 3D Toolkit. We'll create simple and reusable routine. I'm going to provide tips on how to navigate and debug your Dynamo graph. I'm also going to provide tips on how to create your own automation routine. So what to expect? We're going to focus on Civil 3D, Dynamo, and Civil 3D Toolkit. I'm going to provide lots of samples that focus on AutoCAD and Civil 3D nodes. The dataset and presentation will be available for you to download. And now let's focus on Civil 3D Toolkit. What is Civil 3D Toolkit? It's a package created inside Dynamo for Civil 3D. It's developed to supplement the out-of-the-box nodes. Also, it provides enhancement capability that is not available in the current version. So who developed this? Paulo Emilio Serra and Safi Hage, they are the brains behind the success of this package. Why do I need this? Back in November 2019, when it got first released, it offers at least 500 plus additional nodes. It is widely used in the Civil 3D community and is being further enhanced with the help of our Dynamo community. They actually provide valuable feedbacks to our developers. So where to get it? When you open Dynamo in the Manage tab, you can see this search for a package. And then you type in Civil 3D Toolkit, you install the latest version. So where to find it? After installing, it is found in the library side below the add-ons. As you can see here in the Autodesk, under that one, you can see the Civil 3D Toolkit. So how to check versions? Again, if you go to Package tab, you can click Manage Packages and you can see all the latest installed packages in your machine. So what are the current categories available? So we have AutoCAD and Civil 3D. You can see all the subcategories there. And we will focus on this one in this session. We have collaboration, GIS, and land development. We also have pipe networks, pressure networks, and tunnel. So let's talk about reusable routine. Civil 3D and AutoCAD subcategories. This one is a perfect example of a reusable routine. As you can see, I got object types and I'm selecting all object of that type. Currently, I got those options, which is limited. If I select the alignment, I can run and I can get that alignment. Here, I have an arc and I have a feature line here. And if I want to select those arc or feature line, it's not possible as of the moment. But using Civil 3D Toolkit under the AutoCAD document extensions, I have this add new type. So if I select that one, run it, I can see that I have more options. So I got that arc there and the feature line. So if I select that arc now, I can have that arc selected. I can also get a feature line, run, I get that feature line. Document extensions get style and set style. If I select this object or this alignment and connect it here and make it automatic, I'm getting the style of that alignment. So if I select this one now, you can see that alignment have a proposed style. If I want to change the style of that one, I select here. So let me just select this one. Currently it's proposed. And if I select it to basic, it becomes basic. If I change it back to proposed, it becomes proposed. And I'll change it back to basic. document extensions, object handle, and object by handle. You can find them here in document extension, object by handle, and object handle. And if I select an object, for example, this feature line, and I connect it here, if I run it to automatic, you can see that I'm getting that object handle. And if I connect this document current here and that one there, you can see that I'm getting the feature line or the object in Dynamo. And I can check and select another one, for example, alignment, and it will give me object handle and the alignment object by handle, which is this one. Let's talk about document extension again. So this one, if I connect this one there, so that is document extension get coordinate system code. And if I run automatic, what you can see is it will give me this MGA56. And that is actually here in my settings. If I go to drawing settings, it will show me that I have that MGA56 setup. So that's this one. Okay, so that's my coordinate system code. And the other one would be this one, document extension get xref. So if I select this one there, as you can see, I have two xrefs and it should give me those two block reference. And normally those block reference, you will connect it to get the AutoCAD xref block, or for example, the name of that block. So if I connect that one there, then I can get those ACAD xref sample 1 and ACAD xref sample 2, which is the name of my block. And if I want to convert that one to string, of course, I will just connect it to block.name, and then I'll have that string. Okay, so that's that one. And the other one would be this one, get layout. And this one would be this one. It will return the layout in the document. And as you can see, I have layout AAA here and layout BBB here. So that will give me all the layout, including the model, layout 1, layout 2, and many more if I have more layout. And the last one would be this get document style, which will get every single style in my document. Okay, so that's this one, it's new. And if I go and create watch node and connect this one there, you can see that it'll give me the profile style available, the parcel, structural, alignment, label style, all the label style available here will be shown. Another good reusable routine would be this object by geometry. And you can convert Dynamo geometry to Civil 3D CAD, but there's limitation. This one, the arc, if I make it run automatic and go to here, you can see that I've created that arc. Okay, that one. And if I connect this one there, it will show me null. It will not output a null. It will not output a value. And the only way I could make it work is if I use this new tool or nodes, which is arc by geometry. And that one is this one. And if I connect this one there, you can see that I managed to convert that one there. And it's going to be live because I can stretch this one and it's updating. Arc by object and arc.geometry. So that's found here in that Civil 3D Toolkit by object and that geometry. So traditionally, if you want to convert an arc, or if you have a polyline, you select a polyline and then convert that one. So that's converting CAD to Dynamo. So if I run this one, you can see that it will convert that polyline, but not everything can be converted. So if I select this arc, it will not allow me to do that. And for you to do that, you need to use arc by geometry, which will allow you to convert that object to an arc. And then you need to connect here, then you have your arc there. Okay, alternatively, you can connect it here, then you have that arc as well. So this one, when you update, it changes that one. And of course, you can do it this way as well. So that's the reason why you have this arc that by object and arc that geometry. Selecting an object in Civil 3D is available but only limited to selecting one object at a time. For example, here, if I select this object, I can only select one object at a time. I can select another one, but it's only one at a time. But Civil 3D Toolkit, AutoCAD, and Selection provide these select objects. Now you can select multiple objects. So if I select here and select, let's say, those three, then I can select multiple objects. I can select all of them or select a portion at a time. So you can do it that way. Okay, and if I run this one now, then I can convert those into Dynamo. So I can do it that way. I can select and convert. Civil 3D Toolkit allows you to convert a hatch selected from CAD to a Dynamo object. For example, if I select this hatch and I run, you can see that here I managed to convert that hatch. Because of that, I have this geometry, pattern, rotation, and scale, which I can get from that hatch object. So here in this geometry, if I go to that polycurve, I can zoom to that polycurve and you can see that I managed to create a polycurve out of that hatch object. And also I got that rotation, that scale, and that hatch pattern. So if I select this one, you can see that I got that pattern, the angle of rotation, and the scale. Civil 3D Toolkit have this hatch by geometry. So if I go here, it can create a hatch in AutoCAD from a Dynamo polycurve. So here I can select this geometry, and if I click automatic, it will give me a geometry or a polycurve. So if I zoom extend, you can see that that's my polycurve created from that CAD object. And if I use this hatch by geometry and create a pattern and a scale and a rotation, if I bring that one there, it gives me this object because it's using a layer of 0 and model space for the block. You can also connect this one to set the object color. So if I now change it to red, then now I have this red hatch there. Civil 3D have this block reference extension by geometry. And what this one is doing is it allows you to create a block reference from a list of Dynamo geometry. So here I want to create a Dynamo geometry. So if I run automatic, you can see that I'm creating a circle, a rectangle, and a sphere. So if I select this one and zoom to that one, you can see that I managed to create that sphere, circle, and rectangle. And with this, I want to convert all of that one into a block. Okay, so if I connect a location, which is a coordinate system, I want to connect a coordinate system, a block name, and a model space. So this one is model space. It will work like that, or it can also work as null. Okay, so you can do it that way. And once I connect this one there, you can see that I managed to convert this one into a block. So that's ADSK new block name. And if I do object viewer, you can see that that one is converted to a block. Toolkit also have this block reference by object. And this one converts an object to a Dynamo block reference. It also have this get insertion point, which gives you the insertion point, and also have this add hyperlink. So we're going to talk about these three items here. And if I select this object right now, so that one is currently, it's a block reference, and it's a Autodesk new block name. And if I run this one, it gives you that block reference and it gives you that insertion point. So that's what you have. And normally you connect this one here, and when you run, you get the block name and you get the name and the object, which is circle, polyline, and solid, which is that one. Okay. And what else you can do here is you can add a hyperlink. If you go to that extended data, there's nothing in it. right? There's nothing added. And if I hover, it's not showing any hyperlink. But if I attach this one there, add a hyperlink, and add the description, if I run, you can see now that this one, if I select again, it will have that Autodesk website because that's my description. And here, there's a hyperlink that you can see. When I control plus or control click, it will open a hyperlink. AutoCAD layer extension. This one have a layer create node, and you can create by name and color. And you got get, and you got the sets. And here, if I set this one to automatic, currently I don't have a layer called ADSK new layer. So if I click that one to automatic, it allows me to create this new layer. That one is created using this one. And I got those get and set. So if I connect that one to here, I can get all those extensions. So if I go to there, you can see that I can get the layer, whether it's hidden, whether it's locked, whether it's plottable, and so on. And you can also get that layer extension. So if I connect this one there, you can see that I can set all that layer. And that one is for STB, but this one, it's good because you can see whether you can set it to frozen or whether it's locked. It's actually this one, frozen or locked. So if I change it to true, then it will be frozen and locked. And also here, if I this one set this one is on, and whether it's plottable, so that's on and plottable, currently it's true. If I change it to false, then it's off and non-plottable. Here you got the hide. If I hide it, it's gonna be not visible anymore. Of course, I don't want to hide it. I will remove it and it's gonna be visible. AutoCAD MText. AutoCAD MText have this three create, which is that one is finding an MText, that one is by point text rotation, and that one is finding a DText. So here I can create, for example, I have a 45-degree rotation. I can create an ADSK MText. And here I have a sample MText and a sample text or DText. So if I select that MText and select that DText and run, what you can see, it creates me an MText, and this one, it creates me an MText below. So you might want to delete the original one so that you get that one there. AutoCAD line extensions by geometry allows you to create a CAD line from a Dynamo line. So here, if I set this to automatic, you can see that I'm creating that one. So I can just stretch and it creates me my line. AutoCAD polyline extension have get geometry, object by geometry, and offset. So here I can create a CAD polyline from a Dynamo arc. So traditionally, when you run this one, I created this one, a polycurve that have that arc. And normally, when you use object by geometry, it will not return something if you have an arc. But this one, it will allow you to convert that one. So if I freeze this one and run it again, now this one works. I managed to convert this polycurve to that CAD object or polyline. And also here, I got this get extension, which will convert this polyline to a Dynamo geometry. And also I have the ability to create an offset of that one. So if I select this polyline and I have a default offset of 1, if I run it now, it creates me a 1 offset here. So if I make it -1, so I'm creating to the left, 1 offset to the left, then it will create me that one. AutoCAD object extensions can add hyperlink, notes, and reference document. So here, I got my AutoCAD object, and I want to add those information. So if I select this one, I can add this to that hyperlink and that website as a description. And I can also add a notes, for example, here, document notes, And I can also add this document reference. So if I run this one and select it again, as you can see, I managed to add the hyperlink, document notes, and a reference document. So if I go here, you can see that I have that reference document created as well. Object extensions allow you to add and remove X-data. So here I can add an X-data or remove an X-data. So that X-data can be found here, and normally you get that list here. So for example, if I add an X-data here that have ADSK 1070 and 100 for the type code, and I run this one, you'll see that if I click this list and select that one, enter, I'll have this ADSK created. So currently I have ADSK 1. So if I don't want that one, I can select this one again and then run it, and it will delete that ADSK 1. So if I list again and select this one, as you can see, I only have ADSK here. Object extensions allows you to get the parameters and set parameters by value and name. So here, if I select this pipe and I run, I can get that parameters. And if I scroll down, I can see that I have this hydraulic grade line up, and it's actually found here. If I go to pipe properties, I can scroll down and I can see that I got that hydraulic grade line up. So I can change it here, or I can say, okay, I want to change it here and I want to update that one there. So if I do that one, now I will change that hydraulic grade line up, that one, to be 100. So if I run it again and select this one, you can see that now it will be 100. AutoCAD Legend have the ability to create legend. So here it creates legend automatically, and this one send it to AutoCAD. So here I have all those layers, 1, 2, 3, and 4. If I run this one now, it will automatically create those layers and create me a legend. AutoCAD Legend by item allows you to create a legend from a list of legend item. So this one I can create using a legend. Okay, so if I freeze this one, then I can start using this legend item. But for the legend item, I have available to get the by layer line type scale. So I need to have text, layer, line type, and line type scale. So for that, I will need to get all of that first. So I need to get, for example, the document, the first layer, the first 10 layers. So if I run that one, I'm getting a list of those layers. And after that, I get the name. I can use that one as my layer text. And that's the layer I want. That's also the line type and the line type scale. So if I run that one, I will end up having a legend items. And because of that legend item, I can get those information, layer, line type scale, and text, which is those get item. And now I can free this one and run it, because now I will have my legend, because that one will give me that legend auto. AutoCAD layout have the ability to get by name, which is this one. And with that, you can get all the information of your layout. Currently, I have model and layout 1. So I want to get the layout 1. And at the same time, if I remove that one, if I run this one, I'm just getting that layout 1. I can rename that layout 1 to be a new name. So this one would change. So if I run this one, you can see that it's new name. AutoCAD viewport can create a boundary in your Dynamo geometry, so it can create that polycurve and can also get that coordinate system of that viewport. So here, what I got a model space that have this object, and I've created 3 viewports. And with that layout 1, I can get that name and then all those viewports, and I can get those boundary and coordinate system. Because I can get those coordinate system, I can actually convert that one to geometry transform and then use this polyline extension to transfer that curve back to Civil 3D. So if I run this one, it will create me in my model space a transferred version of those viewports. Also, I got so many nodes here, which you can also use. For example, here, if I transfer this to that one, it means you can use all those viewports. So you got viewport boundary, center, coordinate system, scale. So you got lots of information you can use about that viewport. AutoCAD plot styles allows you to get information of your plots. As you can see, I have information here, and this one is for STB. AutoCAD table have lots of enhancements in the Civil 3D Toolkit. So if I select here, I got a table, and I can select that table and convert that table into here and get the data out of it. So if I have a watch node here, I can get all the information of that one. I can also create my own table using a data. For example, here I got a header, and then that's my data. So I can do it that way as well. And I have the text height and then the middle center. So I can do it that way. So if I run this one will give me that information, and this one will create me a new table here. So if I run, I got a new AU 2020 with 1 to 5 and 6 to 10 information. 1 to 5, 6 to 10. So I have that data created. And with this, I have that 1 to 3 and 4 to 6. With this, I can also add information. For example, I got lots of information here. I could get the information. I could add column. So if I want to add column, I can go to here and use this table add row and table add column. Of course, you need to calculate the row and column and do some maths, and you can do that one. So for example, here, if I want to use, I will connect this one to that table and then unfreeze this one. And then I can make this work and add a table here, or column and row. So I can do it that way. And here I can also set that value by row and column. So if I want to use the ADSK as a new value for all my table, for example, all that 1 to 10 will be ADSK, I can use this one and connect it here and then freeze this one. If I run that one, it will get those information. And I have those information there that I can use. So now they're ADSK. I can also change the style of this one, like the color. So set table style is available, where here I'm using those node, set the background node, set the content color, set the value of that table. So I can change whatever value again. So here I'm changing that AU 2020 to ADSK Consulting and all the color. So if I connect this one here and then unfreeze this one, then if I run, then that one changed. So see that style? I changed that one as well. Toolkit have this alignment extension that create alignment placeholder. So it creates you a blank alignment, and also have this create alignment by polyline. And here we got that by polyline. So you need to create using a polyline, and that one is the placeholder. So it's under that alignment extension. We also have this alignment type where you can choose which type to use. So I'm going to pick a center line as an alignment type, and I need to insert a name. So I'm using ADSK alignment 1, and then the rest I can leave to default. And here I got create by polyline, but I need to select a polyline. So if I select this polyline, so that one is a polyline. And as of the moment, I don't have any alignment created yet. So if I run this one now, you can see that I managed to create two alignments. The one, which is a placeholder, and this one is the converted alignment from polyline. So here is an alignment, ADSK alignment 2, which is this one. Civil 3D alignment extension have lots of get item. So here you can see you can get critical station, you can get offset alignment, all of those information, including station equation. So I have here an alignment and I have the offset. Okay. And if I run this one, it will get me my alignment and all the other alignments, which is my offset, and I'm picking the first item. After that, I'm mining all the information of that one. For example, the range start, the range end, the offset target curve. And here, just a sample, I'm getting that offset alignment of that alignment. So I have those two offset alignment, and I can also get the sub-entity, which is line arc line, and also the station equation. So this alignment have a station equation assigned. So that's this one, 160 and 500. It's being picked up there. And also the PI, where that PI is located. The alignment extension have sample line by station, which here, if you go there, you can create a sample line at a station along an alignment. And here I'm getting that alignment and creating an alignment station at 20 interval. So if I connect this station here and I connect that alignment there, I need to have a group. So I'm creating a sample line group, which is this one. And once I run, you can see that here it will build me a sample line group. So here it creates me those sample line, that one. Alignment extension also have this alignment entity here. As you can see, I can add fixed curve, line, or spiral. And you can have the fixed, float, or free here. And it's so many of them, and you could choose which one to use. But the concept of this one is you need to have an alignment, and then you could start adding that one to that entity. So for example, here I got a new blank drawing. And what I want is first to create me a placeholder, an alignment called 1, ADSK align 1. So if I run automatic, you can see it will create me that alignment 1, a blank alignment. And here I will create a point from -100 to 0 and then 0, 0. And then I will create that as my start point, end point to create a fixed line. So if I unfreeze this one, it creates me this fixed line, start point, end point. And with that, I can continue and add another curve. For example, here, I want to get the sub-entity. So I'll connect this one there. It will get me that sub-entity, but it's going to give you a list. So what you do is you want to filter that one to get the first or the last item, because sometimes you have multiple item there and you get the last item. Here, I only have one, so I get the last item. And once you have that one, you can continue in adding another option. For example, here, I want to add a floating curve. So you need to connect the alignment first, okay? And then the sub entity, which is it's attaching to, and then all the information. For example, next, and radius pass through, radius greater than, and curve type. So that option, curve type, you can see that you have option to insert integer, compound, or reverse. Okay, so you have those options, and you got that boolean there. Okay, so if I freeze this one, then it creates me that curve. Keep in mind that you need to do it once because it's a create node. So if you create on top of it, it will confuse it. So you need to be careful on using this one. And let's carry on with this one. So I managed to create a line, a curve. And if I go through here, I can add a floating line of that curve. So again, same thing. I will connect this one there, and it will give me two sub-entity already. And I'm picking the last entity, which is this curve. And because of that, I'm attaching a floating line to that curve. So I need to have that sub-entity there. And then what alignment is that one? And then it's the next one. And then what length? So I'm attaching a length of 50 away from that curve. So if I unfreeze this one, it builds me that one. So that's the concept of this one. Civil 3D corridor extensions have this get TK feature lines and have this get TK feature lines by code. So that one is found here, and it returns a dictionary, and this one returns a list of your corridor feature line by a given code. And what I have here is a corridor, ADSK corridor, and if I run this one to automatic, what I'm doing is I'm getting the corridor, and then I'm getting the baseline. And as you can see, the baseline is a list. And if you connect that one there, you'll have a structured list of level 1, 2, and 3. And here, what I'm trying to do is I'm getting only the baseline. And if I bring that one there, you can see that you're only getting a dictionary of that feature line. So that's just a handy way of getting that information. And below here, it's the same as the one above, but this time I'm using baseline.code. And with this, the code I'm getting is all of that, crown, ETW, and everything. And when you're trying to create or get a feature line, you don't want to get all the feature lines. And I would normally do it this way. I attach this baseline, and I'm just getting a specific of what I need. So here, I'm getting this to there. And if I connect that one there and bring it down here, you can see that this one, I'm just grabbing the crown and ETW, and that's what I'm having here. So I can change this one to, for example, crown ETW till pave 1. So I make it, for example, till here. I'll make it 3 till ETW pave, and it calculates that one for me. So that one is a handy way of getting the information using those. Corridor extension also have this TK corridor feature line, where here you can see it's looking for the TK corridor feature line, and you can mine all the data, for example, code, station, point, polycurve side, and start station. And here you can also get that coordinate system, and you can also get that offset by elevation. So we have this corridor here, ADSK corridor, and I've explained previously that here, if I run this one to automatic, I'm getting the corridor, getting the baseline, and I'm getting the index of that baseline, and then I'm just grabbing all that feature line using that crown and ETW. So here till here, I'm just grabbing that TK corridor feature line. And after that, once you have that TK corridor feature line, you can connect this one to that TK corridor feature line. And as you can see here, you can get the information that you need. For example, here, that's the crown and ETW from that feature line. And that's the start station, which is 0, and it ends at 700. And which side, which is negative or positive 1. And also here, I have that created feature line points and polycurve. So if I select that one, it actually get those information. And if I zoom in a little, you can see that it's getting me that crown and ETW. That's my crown in the middle, and then left and right is my ETW. So that's doable. And also here, I can get the coordinate system and that dictionary of that offset elevation by station. So let's say I want to get the mid of my start and end, divide by 2. That's this one. And here, I want to get all the coordinates of that coordinate system of start to end using 20 interval. So if I unfreeze this one, it gets me all those information. And as you can see here, it gives me those offset and those elevation. And also here, if let's say I got all the coordinate system here, if I make it, let's say A 0, 0, 0, just the first coordinate, if I grab that one, I can select and then zoom to that one. As you can see, that is the coordinate system that I'm grabbing. Corridor extension also have this export as alignment, export as grading feature line, and export as polyline. So let's start with this export as polyline. And what I have here is a generic way. If I run this one to automatic and I unfreeze this one, you can see that I'm just getting all the feature line, even though that they're listed from 1 to 5 structure, it doesn't matter because I'm grabbing all those feature line. So here by default, you got a layer already. So I can just connect this one here. And by that, I'm getting all the polyline created. So in CAD, it creates me all those polyline or 3D polyline. If I select similar and object view, you can see that all of those is being created for you in 3D. Okay, so that's a possibility of what you can do here. And the other one, if I freeze this one, and the other one would be this feature line as grading. And with that, currently I have site ADSK site here. And what you have there is a blank site. There's no alignment, there's no feature line. And if I unfreeze this one, and what I'm trying to do is I'm getting the site, okay, and I'm passing that site to here, and I'm just grabbing the first site. And that goes to that site here. You just need to specify which site. And also here, I'm getting the layer and passing it there. And also what I need is this feature line. So as you remember, I mentioned that instead of passing every single feature line, I'm only passing a specific feature line, the crown and ETW, because if it's a feature line, it will overwrite each other if it's on top of each other. So just grab the information that you need. So if I watch this one, again, the point code, you don't want to get all those point code. You just want to get specific point code, which is, for example, crown and ETW in this case. And that's the one I want to convert to feature line. And with that, it will give me a feature line here, those four, because I'm using FL as the name. So that's how you can create this one. The next one would be this. Again, it's something similar because if I run this one, it gets everything. And in this case, I'm just getting the site again, inserting the site there, and then using that layer. The only thing I added here is this alignment type. I want to create an alignment called offset. And here, I mentioned that I'm getting the crown and ETW. So I'm using the same thing, passing it here. And if I go back here, I managed to create that alignment. Okay, so that's how you create that one. Profile extension have this add PVI. So this one is a add PVI, which you can add a PVI to a profile. But here, I got a profile already. And what I have is an alignment and a profile, which is just the existing ground. So that's my red one is my existing ground. And I want to create a design profile. And we have in our alignment extension to create a profile as a blank profile. So if I run this one, automatic, what it will do is it will create me a blank ADSK profile, which is that's the name. And here I added that new profile. It's a blank profile. And because of that, I'm trying to get the first ADSK new profile. So I'm getting that first item, which is that profile. And currently I only have existing ground there. So here, what I have is a data in for a station and elevation. So I need to insert an elevation and I need to insert a station. So the profile is that one and I need to insert those two. So with the station and elevation, I decided to create a 4, which is a sequence of 4 items. So I get the start station and get the end station, and then I divide it equally into 4 stations. So if I bring that one there, and I randomly place an elevation value as of the moment, 59, 65, and if I connect that one there, all I need to do is to which profile I need to add this station and elevation. And if you check here, if I select that one there, it creates me those profile and elevations. So if I move that one there, I managed to create that profile. So that's using those 59, 65, 63.2, and 69. And if I do profile geometry and here, you can see that that is created using this one and that one. Similar to alignment entity, profile extension have the ability to add curve using free parabolic or symmetric parabola. Okay, so you can add those curve there. And I have here option 1 to option 3, and you can continue all the way to option 8. And as you can see, they're similar because they require profile and they require an input of whether it's radius or by length or by k value. And same thing here, that one is asking for a PVI, which is that's the attach. It's asking for the PVI. And again, it's looking for profile, a PVI, length, or just a length, or a radius, or length, or a K. So that's why I put it as an option, and it's just changing that value that you need, like changing those value. So let's tackle about one example. And previously, we discussed about adding a PVI. So a quick review here is if I run this one, currently I have this alignment already, and that one have created this one, alignment and existing ground, which is this red, and that is my profile. So I'm gonna create a new profile there, and I'm gonna add a PVI using that 4 points with that elevation. So if I make this one automatic, it creates me that blue line. And with that, all I need to do is to connect this one there and connect this one there. And what this one is doing is it's getting the first profile one because it's giving me a list. This one is a list. I want to convert it to get just one profile. And here, the PVI, I got PVI 1 or 0, 1, 2, 3. So I'm dropping the 0 and 4 and I'm getting 1 and 2 or index 1 and 2. And what I need to do is to attach that one to all those PVI. And here, the profile, I'm just passing it here to attach to those profile. Okay, so we're gonna do one example, and here I need to use this profile that entity because I have a profile, I'm grabbing the entity. So what that one is doing is it's grabbing the entity of that profile, and I'm selecting which one's the previous entity, which one is the next entity. It's just handling it by index. So if I do 1, it's asking for a k value of 24, and that's that one. So if I freeze this one, as you can see here, I managed to add that curve there. Profile extension have this profile entity. As you can see, I can get all those information there, like length, end station, end elevation, and even the minimum K value. And what I have here is an alignment in the profile, and what you need to have is a design criteria for your alignment and a design criteria for your profile. So once you have that one, then this one would work. So if I set this one to here, if I set this one to automatic, I got that profile and alignment being taken care of. And I have this, I'm getting that profile MC10. And because of that, I'm getting the profile entity, which is tangent, parabola, tangent. And then here, I can get that value, which is length. So that length is this one. And also the constraint is available. That's fix, free, fix, and also the pass-through, that one, and also the entity type. So that's being available there. And lastly would be here is for the tangent, it's null, but for the curve is 43. Also here, curve is 234. Civil 3D Toolkit profile view have this by alignment point name. And what that one's doing, it will create a profile view from an alignment to an insertion point, and you just need to give a profile view name. And that one would pick the default band set and style, and that one will create you a profile view. And with that profile view, you can get that profile view extent in your geometry, and you can also get a value of that profile view station and elevation based on coordinate as well. So if I run this one, if I make it automatic, what it does, it creates me this profile view. And a while ago, I don't have that profile view, but now I have this profile view new. because I've created that one. And with that as well, if I select this one, you can see that I managed to get that profile view. And also here, I got that 20 and 60, which is at that 40 and 20 elevation. It's at that station 20 and elevation 60. So that is that coordinate is giving me. And also we have here this one, the profile get view, and what that one's doing, if I connect this one to here, what that one's doing is it's allowing you to get the profile view. So we've created that profile view ADSK new, and with that you can get the alignment and you can get that profile view name. So that's this two, getting that alignment and getting that name. Civil 3D PBI is also available in the toolkit where you can get all those information of your PBI. So you got the basic information about elevation, grade in, grade out, headlight sight distance, passing sight, PBI type, station, and stopping sight distance. So I place all of them here. And as of the moment, what I have is this alignment, MC10, and a profile, MC10. And I'm just grabbing all those information. And if I make this one automatic, you can see that I'm grabbing that index and all the PBIs of that one. So I got PBI there, there, and there. And all those information is available if I do the watch node. So for example, start station, you got 0, 418, and 700, and you got the elevation. And also grade in, you can get those grade in and also the grade out. Also the type, you can see that the type would be non-parabola symmetric, and also that passing distance. So you can get those value there. Civil 3D section view have nodes like alignment, extent, find station and elevation, get section view, station, and name. So here, the important one would be this get section view, because it allows you to get all the section view in your model space. So this is my model space. I'm getting all the section view. And after you get all the section view, currently I have all those section view available there. And if I make this one automatic, you can see that I'm also already grabbing all that information. And what you can see here would be your alignment, your extent, and then the station, which is 0 to something, and that one, the name. So that one is this one. And lastly would be this station offset. So as you can see, it's looking for that find station and elevation at XY. And that one is requiring you to get a section view, which is here. I'm grabbing for all the section view, but I'm picking the first or the index 0. So that index 0 is actually here, the first section view, and I already have this one there, which is 1230 and 200. That's your X and Y. And because of that, I can select this one, add a label, and insert it here. And you can see that this and that is the same. Civil 3D selection allows you to grab information from an alignment, corridor, or a surface. So as you can see here, I got surface, and I got alignment, and I got corridor. And if I take this one to run, I have an option to choose which surface I want to pick. For example, that surface, which alignment, and which corridor. So that's the beauty of this one. You can get those information by using those drop down. Civil 3D thin surface extension have this crop. So it can crop a thin surface by a list of cropping objects. And the cropping objects would be a polyline in your Civil 3D. So that one is an object. And it requires a surface. So it requires a surface to begin with. So for example, here I got two surfaces, the design surface and existing ground, and I want to crop this portion, that polyline. So what I do, I select that cropping object. So that's my cropping object. And then I need to decide what name would be that newly created surface. So I need to call it, for example, ADSK crop demo, and which surface I want to crop. So I want to crop this. So I will connect that one there. And then lastly would be the coordinate, which one to keep, because you can insert it, keep inside or keep outside. So this 400 negative 500 is actually inside that box. So if I connect this one there, and then I can run, and you can see that this one would work. So if I run, then it creates me this one, a newly created crop surface, which is that yellow. And if I change this property, and let's say I define that one to be contour and triangle, it will show up like that. So it's a newly created crop surface. Thin surface extensions allows you to extract solid from surface. So you get that one that requires depth, fixed elevation, and between surfaces. This is actually from here and that one, and extract solid from surface. You have this depth, fixed elevation, and between surfaces. So let's try this one. Here, you're not allowed to have negative. You're only allowed to use positive, and if you want negative, you need to translate it. And this one, I'm using no path, meaning it will be in this drawing. So if I run, I have that solid created, which is this. That's my solid. Civil 3D Thin Surface Extension have the ability to add breakline, and you can add non-destructive, proximity, standard, and wall. They're actually type of breaklines. And here, when you select a surface, you can add a breakline and you can choose that type: standard, proximity, wall, and non-destructive. So they're basic Civil 3D breakline type. And you can do that one in the toolkit. And here, I have a surface existing ground and I don't have any breakline added. And for now, let's talk about adding a breakline. So if I select this object and I want to add that as a breakline, so for example, this standard breakline, if I run, it will add it to my surface. So that's basically what that one's doing. And I can go to my surface and let's say I don't want that breakline to be added now. I'll remove it and rebuild, and it's got rebuilt. And let's say I will freeze this portion, and let's say I want to add that proximity. Then I can run this one again. And here, if I go to the surface, it's actually adding me that proximity breakline. And if I have that surface auto rebuild, then anything that I will modify here, it will update. For example, if this is a proximity, so it means if I do it till here, it will change everything. It will update as approximate to that breakline. So that's that one. And for this wall, it will update in the future. Tips in navigating your Dynamo graph. It is important to analyze what is the purpose of this graph. What are the inputs needed and what are the outputs? After analyzing, you need to understand the graph. Structure the nodes with groupings and run the graph step by freezing nodes. When you are modifying, look for ways to make the graph as efficient as possible. You need to understand error messages or state of node. That will help you debug any errors. Tips in creating your own automation. Which task to automate? You need to identify repetitive design tasks and focus on creating a small and reusable routine. Ask yourself, is it measurable and scalable? Can I measure the time that I will save or cost savings? Is it scalable in small and bigger projects? Will you be able to reuse and recycle the routine in your next project? Is it manageable and easy to modify? If you plan, create a strategy, and make effort, it will help you find the solution in creating your own automation routine. Thank you.